Welcome to Qt Widgets and More. In today's episode, I again have Pepper with me. Pepper will answer a simple question. Sometimes simple questions don't have simple answers, but the question is, should I be using exceptions in my Qt application? Can I even use it just for my own little part? Welcome, Pepper.
Hello.
So, yes, the question is really simple, but before we get there, can we just go over the very basics? What is an exception? Does it cost me anything if I don't use it? And those things. And I'll give you 1 minute for that at most.
So you wanted a simple answer to that? Okay, the answer is not so simple, but I'll try to give you the very short version. C++ as a language has support for exceptions. We use exceptions as a structured form of error handling. So when something goes wrong, you have a structured form, by structured I mean in terms of your source code organization, way of handle that something that went wrong. However, that also comes with some downsides, and that's the reason why many people don't use exceptions. There are performance considerations. Throwing exceptions is, generally speaking, expensive. There are engineering considerations, like the fact that if you are using exceptions, you should write your code in a way that is able to cope with the fact that you call a function and that function now throws some exceptions back to you, and then you need to handle it. And so for these reasons, well, there are also other reasons, but for these reasons, sometimes some projects may decide, you know what, better off without using exceptions, at least as far as my code is concerned.
And the next question, which will also be a very short one to answer, I'm sure, is Qt being this tremendous framework that can do anything that you want, more or less. It can do XML handling and JSON and list views and QML and whatnot. Why is it not using exceptions? That seems like it would be a good idea, wouldn't it?
Well, perhaps it is another answer of what if Qt was designed from scratch today, then perhaps it might decide to use exceptions here and there. As things are, Qt has been designed some 25 years ago. 25 years ago, yes, we did have exceptions, but supporting compilers was kind of a hit and miss more than actually being properly consistent and usable everywhere. Some people, again, back then also maybe decided to compile with the entire exceptions disabled because they couldn't rely on the compiler to generate good code in the presence of exceptions. So, as I say, the reasons are mostly historical at this point, but it's not that Qt tomorrow morning will decide to start throwing exceptions. Indeed, if you look at the entirety of the Qt API, you will not find a single place where Qt tells you, okay, if you call this function and something goes wrong, I will throw an exception back to you. Qt decided to go for error codes. Qt decided to go for optional types. Not necessarily standard optional, because that's relatively new, but you have all these isValid or isNull methods that you can call when you call a function, it returns a value to you, and then you can check, is this value okay, or did something went wrong? And so you check if the value does actually contain something, and then you use it. It's another approach, right? It's not exceptions, it's error codes, it's just returning information, double quote, normally. But that's what Qt does, and that's what it will do for a very, very long time.
And that is one of those things that is sometimes even hard to get out of the mindset. I mean, Qt date : is valid is one of those that you're talking about.
Yep.
And I've so many times implemented stuff where I started doing is valid, and then at the end of the day, I was like, wait a minute, Jesper. It's just an optional that you're implementing around your data structure here. So skip that is valid thingy. Okay, but the next question, of course, is if I want to use exceptions in my application, because after all, it is 2023 and exceptions are pretty supported by all compilers, I certainly hope these days. And I have a somewhat complex application that would like to do exception handling. Should I just go and have another cup of coffee and get my mind straight, or can I do it? And more down the road, if the answer is no, you can't do it at all, then I guess this whole episode is rather moot. But so the question is, can you tell me what should I be careful with when I'm using my own exceptions in my applications?
Yeah, so of course, inside your own application code, you can use exceptions. Okay, that decision is entirely up to you. Do you like them? Do you feel comfortable with them? Then please do use exceptions. In some cases, the decision is made for you by someone else, not your boss, perhaps. But let's say that you're using another library, not Qt, but another library which does maybe aggressively use exceptions in its API. So in that case, you know that you will have to handle the exceptions that this library may return back to you. And once you're in that situation, then you may decide, you know what, why don't I just start using exceptions also for myself? So rather than just when I interface with this library. But in any case, you will have some exceptional handling code, right? So should you use them or not? I mean, I can give you lots of motivations for using them and lots of motivations for not using them. I think the C++ community is a bit split on the issue because there are arguments good arguments in either direction. But let's assume that you want to use them. All right. If I tell you don't use them, then indeed this we can end up this episode right here, right now. Suppose that you want to use them. All right. Let me tell you a little bit about what this has to do with Qt. After all, this is Qt widgets and more. So suppose that you have an application and inside your business logic, you're using exceptions. What does this mean when you want to interface this business logic with a Qt UI? Okay, I think that is pretty relevant because, as I'm going to tell you in a second, Qt does not quite like exceptions itself. So not only doesn't throw exceptions, that's okay, just a decision, but it does not really like that you may throw exceptions through Qt code. And that is kind of important because sometimes people may, let's say, misunderstand what Qt can do in certain scenarios or how to design certain interfaces that are implemented using Qt. And if exceptions are involved, then things can go wrong quite fast. So it's important to know what are the drawbacks of all this.
I have been teaching you how to teach, and there's always 3 fingers. So shall we start with the first one?
Let's start with the first one. Yeah, so indeed I got 3 examples. Guess what? I got 3 examples to show you, I would say, 3 different ways, 3 different examples of things that may go wrong when Qt is involved. Okay. I'll start with something relatively simple, something relatively basic. So as you can see here on my screen, what I have here is a very simple class, value class that I'm going to call data. Is as generic as it may be. And suppose that for whatever reason, when you make a copy of this data, the copy constructor of data may throw an exception. To give you a concrete example of what I'm talking about here, consider a class that may allocate a resource when it's being copied, or may need to acquire a resource. All right? Example, memory. Okay, your class is something like standard string. When you copy a standard string, you need to allocate memory. That allocation may fail. So I'm trying to be as generic as possible just to tell you there are cases where a copy constructor may throw exceptions. Fair enough.
Okay.
So now let's take this data class, and as you can see on the bottom, I'm creating a vector of data objects. So I'm taking a few data objects and I'm trying to push back them into this vector. Now take a look at the vector class that I'm using. That's QVector, and there are many videos of mine discussing the Qt containers. Links are always down there in the right places. So what I'm doing there is that I'm just trying to add these objects into the vector. Now, when you push back an object into the vector, with somewhere within the pushback implementation, Qt will have to create a copy of your data object or a move of your data object. Let's not complicate things. Let's assume it's a copy. Also because it is a copy in this case, the class has a copy constructor, it does not have a move constructor. So what happens when Qt is going to invoke that copy constructor? It means that an exception may get raised at that point in time. Okay, so imagine the call stack. We are in this code. Then I enter pushback, and I get into Qt internals, and then there is a call to the copy constructor that may throw. So what happens when that happens? When that exception is raised? The exception will have to propagate back through QVector code, and in theory back to me, back to the caller of pushback. That's at least the theory. All right, so what I expect here to see, as you can see here, that I'm trying to push back a data inside my vector, and I'll know that this will raise an exception, or may raise an exception, so I protect the insertion with a try-catch, and if something goes wrong, I act on the exception. That looks fine, but this is somehow having an assumption in mind, that is that pushback's own code is actually safe, is actually exception safe. That is actually able to let an exception propagate through it, and eventually let you handle the exception in a clean way. And a very sad matter of affairs is that QVector pushback in Qt may not actually be exception safe. To state this a little bit broadly, Qt containers are not exception safe. That is, there are code paths in there that, if they encounter an exception, will corrupt the vector data structure, or the list data structure, or whatever container we're talking about. Okay, and this is kind of disastrous, because suppose that the exception is raised, now you no longer have any control over the state of the vector. It may start reporting, a wrong size or a wrong capacity. It may have partially constructed objects inside of it. It's corrupted, right? That's really the worst case scenario, because this practically means that now your program is on the verge of crashing or breaking in mysterious ways. So the point is that if you don't have exception safe code, if you don't have any exception safety whatsoever, you can no longer allow any exception to be propagated through that code. And the Qt containers have this issue. They are not designed with exception safety in mind. So things may go wrong, right?
And for those of you sitting at home looking at the code there and saying, okay, so we're catching the exception, this is actually the result of Pepe trying to prove to me before the recording of this episode here that it would go wrong, and whatever he did, he couldn't get it wrong. But just because he couldn't find an example where it went wrong doesn't mean that it will go right all the time. And it might, who knows, be actually doing the right thing with pushback, but in place back any of the other methods. And there's a lot of methods on QWidget. One of them, on QVector, one of them might actually not be doing the right thing. And if you're sitting there saying, so what could the wrong thing be? Well, think of what will a vector do when it's update. It has a number inside it that is the length of the vector, and then it has a memory array that it actually puts stuff in. And if it updated that number first, that's what we were trying to force it in this example here. If it updated the number first, then an exception or thrown, we would have a invalid element that it thought was in there. Okay.
Yep.
Pepe. That's number one. Number two.
Right. So, let me conclude here. So that is, okay, so if you really want to have a vector of data objects, does this mean that we cannot have such a vector? No, that's not true. What you can have is, what you can do is not use QVector or not use a Qt container in the general sense, but for instance, use a container from the standard library. So standard vector instead of QVector does offer you stronger guarantees in terms of exception safety. So for instance, standard vector tells you that if you throw during a pushback, then the state of the vector gets resetted to the state that it was before the pushback. Okay, that's an exception guarantee that is in the standard. And that's good, right? That's what we're trying to do here. The fact that the one in standard library is guaranteed to do so, and it's auto-tested, and there is probably millions of people relying on that behavior. The one in Qt is unfortunately not guaranteed, not auto-tested, and there's probably no one relying on that behavior right here and now because things may go wrong very, very fast. So, as I say, there is a workaround. I'm not saying don't ever create a vector of data. That doesn't make any sense. But you need to use a class which indeed is exception safe, and Qt containers are not. So that's number one. Now, number two. Let me change.
No, you can't do it. Pepper, you can't do that.
Number two.
We need the drum. We need the drum roll first.
Oh,
And
okay.
number two.
Please insert drum roll sound while I scroll to the relevant code. Well, it's just over here. So comment a few things around so that I actually have this code running. And yes, please. Okay, so number two. Number two is relatively simpler, but it's also very much, again, Qt specific. So in Qt, we know that we have this thing called signal slots, okay, as a communication mechanism between certain objects and other objects, okay, certain parts of your application and other parts of your application. You can think of these at any level of granularity that you like. But ultimately, what is, for instance, a slot? A slot is nothing but a regular function that is inside an object. It's decorated a little bit. So we have to write this inside a QObject subclass, put the marker, add public slots. We know the drill. That's not the important part. The important part is that this is a regular function. And as any regular function, this may decide to throw in case something goes wrong. So here I got a slot. It's very aptly named a slot. Okay. And I take an integer. If the integer is too big, I don't like it, I'm going to throw an exception. Now, I'm insisting on this thing being a slot because I'm imagining that its primary use case for this function is actually going to be connected to a signal. So somewhere else, well, just above, I got a very simple class that just has a signal, a compatible signal, one that carries an integer. And so in your application, what you're going to do is do what's on the bottom. You got a sender object, a receiver object, and you're going to connect them together using connect. And yes, Jesper, I know I've seen your video that also in Qt 5, the receiver does not need to be a QObject. You can connect any callable, but again, stay with me for a second. I'm trying to keep the syntax as simple and as streamlined as possible, all right? So now the connection is up, is established. We know the syntax for QObject connect. Those are 4 arguments. Okay, sender, signal, receiver, slot. And sometime later, I do emit the signal. So, of course, I don't do that in my ordinary code, but again, for the sake of the exercise, I'm emitting this signal, and this is causing the slot to be invoked through the connection. Now, if it's 5, everything is fine, but what happens, of course, if I pass an argument that is going to cause an exception to be thrown? Here things are slightly more complicated, because who is actually calling the slot? So, I'm calling the signal here. I'm emitting the signal, and then there is something in the middle, which of course is the Qt magic, is the implementation of signal slots, and that is then ending up calling the slot. The slot is throwing, that's fine, but that means that the exception is now propagated through a little bit of glue code before it eventually reaches my emission code down here. Okay. And so once more, we must ask ourselves, is that glue code exception safe, or is that going to leak memory or crash my program sometime later? Now, in this particular case, I can tell you, because I've studied the code in the past a few times, I can tell you that that particular piece of code is actually exception safe. So it is fine, technically speaking, to throw an exception from a slot. And what will happen is that the exception will travel through the signal emitting code within Qt and reach the emission point where you're emitting the signal that is connected with the slot. Okay, so from a C++ point of view, from it's not even C++, from an implementation point of view, this code is fine.
But given that it's not crashing inside of the signal emission code, doesn't give us the semantics understanding of a signal slot, though.
Yeah, that's...
I'm more thinking about what happens if you connect multiple slots to the same signal. At least when I do Qt trainings, I tell people, hey, that you shouldn't know which order they are called in. Of course, there is an order. Of course, you can look in the source code and see what the order is, but you shouldn't care about that. But now the first one throws as an exception, and the others will, of course, not be called.
Yeah, so you start having this kind of implications. Of course, one is that, so that the logic of having a signal slot connection, which is actually a many-to-many connection. When you think about it, you can connect a signal to any amount of slots, and one slot can be connected to any amount of signals. But as you say, what are the semantics now of this signal to slot connection? You get an exception back and you don't call some slots. Is that a good thing? It doesn't look that good to me. In general, it looks like that using an exception, you are somehow making some information passing from a given slot to the signal. So the information, instead of traveling from the signal to the slot, as it's supposed to travel, now it's somehow backflowing. It's going the other way around, in which one random slot is telling something to the signal, and that signal now has to handle it some ways. Now, I'm not saying that is useless. I'm just saying that that is not what a signal slot connection is supposed to represent inside Qt.
Can you hear that sound, Peter? I think it's a drum roll because time is running out. Number 3.
All right. So let's continue on this. Let's continue at a steady pace. Number 3 is another similar example, but this time is at a different level rather than a signal slot connection. So what I have over there and what I have down here is a very simple. It's a very simple class. It's a QWidget subclass. Okay. In this QWidget subclass, I have an event handler. It's a mouse press event, but it could be anything. And once more, in there, I decide to do something. I decide to trigger some business logic because the user clicked on a given position on my widget, and something goes wrong, and I decide, or I throw an exception out of there. So that makes sense, right? But what happens again now? So who is calling the mouse press event? Because that question is important because that determines who is going to get the exception back. Now here there isn't even double quote a sender. There isn't a signal that is getting emitted. The event is being popped from an event queue somewhere within Qt, and then it's traveling through various layers of Qt code until it reaches my mouse press event. So the moment that you throw from there, you're basically throwing an exception back into Qt code. That Qt code does not know what to do with your exception at all. It's generic Qt code whose job is simply to dispatch events around and make sure that everything works fine. It doesn't know at all that the semantics of this particular widget have to be handled, have to be complemented or finalized using some handling for this wrong click exception. So now we are in a territory where this throw does not even make any sense because there is no one that can actually catch this exception and do something meaningful with it. Eventually, that call stack, the call stack that starts, that has the mouse press event on top and then goes all the way into Qt, will reach exec. Will reach application.exec because that's where we enter the event loop. Then we pull the events, we dispatch them, and then we reach on top mouse press event. So in theory, you could expect, all right, so I can use this as a last resort exception handling mechanism. Can I put a try catch around exec and say, you know what, I got an exception here. Something went really, really wrong, but at least I can handle it locally and log some information.
Please call this phone number here.
Which one? Oh, yeah.
What would you do at call support? Yeah.
Exactly. But I can tell you that doesn't work. That doesn't work at all for at least 2 important reasons. Reason number 1, that all the layers that your exception has to travel through are not exception safe at all. Again, I've seen the code. They're not being engineered with exception safety in mind. But if you actually do the exercise and try to put like a breakpoint over here, maybe do it at home. It's an interesting exercise. Put a breakpoint inside an event handler, run your code, and see what the call stack will look like when you hit the breakpoint. Well, you may notice that on certain platforms, some of the frames on the call stack are actually not even part of Qt. They're part of the operating system, or they come from a third-party library. And these frames are actually made of C code, not even C++ code. And so you cannot make an exception bubble through or propagate through a C function. It will never work. So there you got a massive problem. So long story short, do not ever throw out of your event handlers. Okay, not only does it make any sense, but it is almost always incorrect because there is no implementation possible that will save you. Because you're going to go through C code, and then your application is in trouble. So if I have to summarize, number one, data in a container. Where was it? This data example. That's fine, but don't use it in Qt containers. Right. Example number two, exception thrown out of a slot into a signal. This works in practice with an asterisk at least, but the code is there to support this use case, but it somehow breaks the semantics of signal slot connections. Okay, they're not meant to be used this way. They're not meant to be used to propagate information, even an error condition, from the slot into the sender. That looks like the wrong kind of coupling between parts. Third case, event handlers, so mouse press event or whatever it is. An exception here does not make sense at all. So it looks like the wrong tool for the job. You should be doing something else rather than throwing from an event handler.
And actually, now you without even knowing it, might have answered my very second question. Why doesn't Qt do exceptions inside? Of course, they could have improved the QVector so that it was exception safe, but stuff like we discussed with the signal slot emission of multiple slots, there is no good answer to that.
Yep.
Or if you throw an exception into the event loop, where would it stop the exception? What would make sense for it to stop? And if it just said, okay, the function that calls into your code, I'll stop your exception right away when it enters my code. Well, what would be the purpose of throwing an exception into the event loop then? And there is just no good reason or no good answers to those two questions. So I guess that to an extent is at least why event-driven applications like Qt doesn't do exception handling very well.
That is more or less a complete answer, yes. Now, you could complicate things and perhaps handle exceptions through an event loop. I'm not saying it's not possible. C++11 added a lot of helpers to be able to transmit and transport exception objects across various parts of your application, because a lot of times the handling of an exception is not local, or it's not supposed to be dependent on the call stack. Maybe at a certain point you say, okay, you know what, package this exception in an object, let me transmit to somebody who can handle it, and then that somebody at the other side handles the exception. But that's not Qt. Unfortunately, that's not what Qt does, all right? So all these mechanisms don't exist, so please don't do that, or your life will be considerably full of pain if you try to engineer this thing and you're basically going against Qt's own design.
Okay. I got a pretty intense and thorough answer to my question here. I can use exceptions in my application is what I take away, but I should be careful not using Qt containers, not throwing over signal slot, and definitely not throwing into the event handler. Pepe, thank you very much for your participation.
You're welcome.
Once again.
You're very welcome. See you next time.
See ya. Okay.